Hey guys, welcome to 0.9 while loops. So in this lesson, what we're going to do is learn to create these while loops that repeat code conditionally based on Boolean variables and comparison operators. We're going to be brainstorming multiple solutions. Our programs will be passing input-output tests. Our code should meet specifications, and we should be using relevant mathematical formulas. All right, so basically, when you're writing code, quite often we have to repeat code until some condition is met. The problem with for loops, which is what we've worked with so far, is that the number of times they run is determined by the size of the iterable, or in this case, the range object, right? If we have for I in range 10, this means do this code 10 times. We're going to run this block right here 10 times. So in this way, they're somewhat inflexible because they run a specific amount of times, and but this flexibility is available in a while loop, which runs as long as the condition in its flow control statement is true. So we use these when you don't know how many times you need to repeat the code, right? So a while loop looks like this. It says while condition is true, do this code. Brackets aren't necessary here, but I'm just trying to show that this is the condition that goes in a while loop. Now, of course, a while loop is a block, just like if or for. Don't forget to put a colon at the end and indent the following code, okay? Because whatever you put here that's indented, this is going to be the loop that repeats as long as this is true. So because while loops repeat their block as long as the condition in the statement is true, this can lead to a problem that many coders have, well, that every coder has faced at some point, which is called an infinite loop. So let's look at this example. So this says while 0 is less than 5, and you don't really need the brackets here. Print hello. So this while loop, okay, will check the condition, is 0 less than 5, and if it is, it will print hello. Right? And then once that's done, it'll go back and check the condition again, right? And this condition doesn't change, right? So this 0 is always going to be less than 5. Because of this, we have an infinite loop. So when this runs, what we should see is literally hello being printed indefinitely, right? Infinitely. And this would go on forever if we left it. And the only way to actually stop this now is to press the stop button. You can also press Control-C. That's a keyboard interrupt. Okay. VS Code luckily is smart enough to give us some options to get out of an infinite loop. So if you suspect that one is happening in your program, you can do that. You can press stop or you can press Control-C. And this is kind of nice. Like 20 years ago when I was coding, IDEs would literally just freeze up and have to be shut down, right? You lose your work in some cases if it wasn't saved and your program went into an infinite loop. So, the state of software now is a lot better, but in any case, right, so this is essentially the same as saying while true, print hello, right? And so the key here is whenever you use a condition, you have to make sure that at some point this condition becomes false so that the loop ends. Or use the break statement to get out of your loop under some condition, which you've included in the block of your loop. And there's some examples later that will illustrate that. So this example is a little bit silly, but let's look at one that is a little more realistic, something we might actually be interested in doing. Let's type this code. So delete this and type x equals 10, and while x is greater than 1, x plus equals 1, print x. Okay, so let's look at this for a moment. So we've given x a value of 10 initially, right? And then we've created a while loop and said, well, x is greater than 1, add 1 to x and print it. So what do you predict this will do? So just pause this for a moment and predict what this program will output. Okay, well, let's try it. So if we press F5, what you'd notice is that your program starts counting, and it should be counting quite quickly. Maybe depending on how fast your computer is, it will affect the speed of this, right? So mine's already up at about 14,000 on my i7 2600K. That's overclocked a little bit. But if your desktop is a little bit faster, yours might be at 30 or 40,000 by now, or who knows. In any case, this is clearly an infinite loop. This is never going to stop. So how could we modify this code? So pause the video here. Think about how we could change this so that we get say just a few numbers printed. Okay, so let's just define the problem here, and we'll say print the numbers from 1 to, or even say from 10 to 20, inclusive. Okay, so we want our while loop to print 10 all the way through 20. So we have this initial value of 10, and we have then our while loop. And what this is currently saying is while x is greater than 1. And we know that that's going to be true while x is 10, right? But the problem, of course, is that right now we're adding 1 to x, printing it, and going back, checking this again. Well, and we know that as long as we keep adding 1 to x, this condition, well, x is always going to be greater than 1. So if we want to stop at 20, right, then what we could do is modify this condition. We could say while x is equal to, less than or equal to 20, right? So then this as soon as x is incremented to hit 20, right, it will print it and it will check this and say, uh-oh, x is 21. I cannot run this loop, and it will go down to line 6 and continue executing whatever code you have in the rest of the program. So let's just run this and see what we get. Okay, so you notice that we got numbers from 11 to 21. Well, that's not quite exactly what we wanted, is it? Right? So how come that's the case? Look at the code for a moment and determine why we started with 11 and finished with 21. Okay, so hopefully what you notice is that because x starts at 10 and we add 1 to x before printing x, right, the actual first thing that we see is 11 because x becomes 11 on line 4 as soon as the while block starts, right, and then is printed. So how could we overcome that? Well, what if we just print the value of x before we increment it? So this way, it will check x will be less than 20, it will print it, and then it will add it and go and then check it again and see if we're still less than or equal to 20. So if we press F5 now and check the output, there we go. 10, 11, 12, all the way to 20. So that's the correct behavior. And at this point, you can pause the video and go to Replit and do 0.9a, which will give you some practice with the basic loop. All right, welcome back. So I want to talk next about input validation. So let's say you got a nice program that you've written, and you're trying to get an integer from the user, trying to take input. But the user is typing in whatever they want and crashing your program because you can't convert that to an integer. Well, you can use a while loop paired with a try except block to create a watertight solution for input that won't allow any shenanigans. This is super cool. So let's look at example 1. Write a program with input validation that asks the user to enter a number between 1 and 10 inclusive. So let's type this out first. Example 1, input validation. Start with a while loop. While true, try x equals float, input, enter a number between 1 and 10. Okay, if 1 is less than equal to x, less than equal to 10, break. Okay, accepts, pass. Here we go, and back here, print invalid inputs. Okay, so just take a minute and make sure that you've typed that out just like mine. Okay, and so let's look at this for a minute. So of course we're starting with this infinite loop while true, but because we put a break statement in here, right, this is going to end the loop as soon as this code runs, as soon as we reach this statement, right? And so this isn't technically an infinite loop because it will break as soon as this condition right here is met. So what this is going to do is it's going to run, it's going to take some input inside a try block, right? It's asking for a number between 1 and 10. And it's going to try to convert the input to a float, right? So if whatever is input cannot be converted to a float, right, then what'll happen is it'll instead of throwing an error and crashing the program, it will jump to the except block and it'll run this here. Now pass, okay, is a special keyword that means do nothing, okay? And if you're going to have an empty block, which is kind of what we want in this case, you can use the word pass. And really this means just go to the next step, right? And so, in other words, we don't want the program to crash, but we don't need to, to basically run any special code in this except block. So, at that point, the try except block finishes. It goes here and it says invalid input, right? And because we're still technically inside the loop of the while block here, right? We didn't hit break. It's going to go back up here and it's going to do the try block again, right? And it's going to try to take another input, convert it to a float. So if the user then does type in a number between 1 and 10, and that this float conversion function is successful, then it's going to go here to the next step. It's going to check this condition, all right, and see if x is between 1 and 10 inclusive. And if it is, it will break the loop and input will proceed to line 16. And we will now have a number between 1 and 10 in variable x, which is what we wanted. Let's just test this and make sure this operates correctly. So here we go, enter a number between 1 and 10. So if we type 3, invalid input, right? How about 30, -5, right? Literally, you could type anything in here. It doesn't matter. The program's not going to crash though, but as soon as you type, 4, then the program will end because we typed something that's acceptable. Okay, let's look at the next example. Write a program to require a negative number or one greater than 100. Well, what I want to do for this really is just modify the current example because really all that changes here is the number, well, the prompt should change, but this condition is going to need to change, right? Because we want something now that's less than 0 or greater than 100. So let's change the prompt. Enter a number, a negative number, or a number greater than 100. Okay? And so if we get a float out of what the user inputs, then this condition is going to check. In this case, we need to change this to make sure that x is, first of all, has to be either less than 0 or, right, x needs to be greater than 100, right? And because this says negative or greater than 100, right, we don't want it to be equal to 0 or equal to 100, so we just use the less than and greater than symbols. Let's just test this out again. So if we type in a bunch of numbers, in between, right, 2, 3, 4, 5, 6 letters, etc., we don't get any good input. But if we type 150, it ends. Okay? And so basically the idea here, right, is that whatever input you want, you use this condition, okay, to quantify the number that's entered. And you use the try except block to make sure that you're actually getting a number, right? Something that can be converted properly according to whatever data type that you want to input. Okay, so you can pause the video here and attempt REPL assignment 0.9b on numerical input validation. All right, welcome back. So the next thing we're going to look at is the Boolean in operator. So the Boolean in operator evaluates to true if something is found inside a list of things. So here is the syntax. You write literally, you can write if something in, notice how there's no is in here, right? If something in list of things, then execute this block. So let's just do some terminal work here to really understand this, right? So we'll go into our terminal, type Python. And now remember, right, the range object, if we type list in front of it, will show us the contents of a range, right? So list range 3 includes the numbers 0, 1, and 2, right? So if we basically use this in operator, okay, we can create a condition by typing the number. So 1 in range 3. So of course this is true. What this means is 1 in range 3. Well, we know that range 3 includes these three numbers, 0, 1, and 2, right? And so therefore it's true. How about 2 in range 3? Well, that as well is going to be true, right? Because the number 2 is right there at the end. But if we say 3 in range 3, well, we know that that's false because the number 3 is not inside that object because range 3 stops at 2. Starts at 0 and stops at 2. So we can also use this with strings. So let's say we want to check if the character A is in the string A, B, C, D, E. And we know that that as well is true, right? Because it's sitting right there at the front. But if we typed J in A, B, C, D, E, right, that would be false because it can't find the string J inside this string. Another one, how about cat in concatenate? Well, it can find cat, right? The whole thing sitting right there inside concatenate. So you can use the in keyword to basically check if something is inside some sort of list or a collection of things, like a range object or a string. Now you can also use the negative version, okay, by including the word not in front of in, right? So if something not in list of things, this would return true if that thing can't be found. Okay, so in other words, up here, right, we know that J was not in A, B, C, D, E, so if we type J not in A, B, C, D, E, A, B, C, D, E, then this is going to be true, of course, because we can't find J, right? You can't find J inside here. Whereas if we typed 2 not in range 3, that's going to be false because we know that 2 is, in fact, in range 3. So let's look next at example 3, which says write a program to ask for a string that 1 starts with the letter A, upper or lowercase, 2 contains the word goat or horse, and 3 has no vowels, right? So let's go up here. We'll write example 3 boolean in. Okay, is kind of what we're showing here. Okay, so we want to ask for some input, basically, right? And the thing is that when we're taking a string input, we're not going to need to convert that string to a float or an integer, right? And these are risky functions because these can crash the program. So when you're taking string input, you generally really never need this try except block. Things get a lot simpler, right? We can use a while loop to force the user to keep putting input in, like up here, but we don't need the try except block. So let's start this program by taking some input. All right, and we'll say x equals input. Type a word that starts with A or A. Use double quotes there so that we don't need escape characters. Okay, so the thing is we've got input now, but we don't really know if this string that they typed in starts with little a or capital A. And so let's start a while loop that will force them to do this if what they've typed does not pass. So we'll type while, okay, and at this point we need to check, right? We need to check the first letter of this string. So while x 0, right? Remember you could use a slice here. Dot lower, so let's say that they've typed a capital A, we'll just convert this to lower case, right? Is not equal to A. Right, so what does this do? Well, this basically says, is the first letter, the lowercase version of it, equal to A? So if they type something that does start with an A, right? A small a or a capital A, courtesy of this lower function, then this while loop will not run, right? It will not run. But it will if they did not type something that starts with A or capital A. So what we need to do then is print right here invalid, right? We're told to print invalid. So we'll say invalid, and then we'll take our input again, right? So you can copy and paste this, put it right inside the loop like that. All right, and then what this will do, right, is it'll print invalid and it'll take input again with the same prompt, right? And then it'll go back, because we're in the loop now, it'll go back and it'll check the first letter of the new X that was assigned by this same input statement, right? And if it passes, then it'll go on to line 22 because the while loop will end, right? So let's test this out and make sure that this works properly. So let's type some stuff. Oh, I guess we should comment out all the rest of this so that we don't end up with any more competition here. Okay, so type a word that starts with A or capital A, right? So blah, 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 right? Invalid, right? We can type numbers, we can type anything, but as soon as we type something that starts with A, then it's happy. And that's what we wanted. Okay, let's go to the next part, which says contains the word goat or horse. Okay, so for this example, for this part, we want to make sure that whatever they type here, right, in this case, is going to contain one or two of those words. So let's go ahead and we'll call this example 3 part 2, and we'll comment out this one. There we go. So this time, we'll start with an input statement, just like before. Type a string containing goat or horse. Okay. So think about what we have to include in the condition of the while loop, right? So we'll make another loop here that will run if they are not complying with our request, right? Pause the video and see if you can think of it. Okay, so we need a loop here that's going to run if our string doesn't contain goat or horse. So another way of saying that is that x doesn't contain goat and it doesn't contain horse, right? This is the only situation where we would want to take input again, right? So we could say while goat not in x and horse not in x. We're going to print invalid and take input again, right? So we can grab this, Control C, Control V. So let's just take a moment to think about why this works. Well, remember that when you make a while statement like this, whatever you put here, this condition has to be true in order to run the block that follows, right? So when we use an and, a Boolean and, right, that means that this has to be true and this has to be true, right, in order to run this code. So if we, for example, were to type goat for our string, right, well, it would come here and right away it would check this, goat not in x. This would return false because we actually just put goat in x, right? So this would be false, right? And so because we have a false here, all of this is going to be false because we needed true and another true here. If we just typed horse in for x, right, then, well, as soon as it checks this would be true, right? Because we don't have goat in x, we have horse. But for this part, of course, we have horse in x, right? So this part would return true. But in any case, we didn't have, right? We didn't have a goat in x, and so this would of course all be false again. The only situation in which this would return true would be if we had no goat in x and we had no horse in x. Okay. Let's just take a minute here to consider what would happen if we'd used or instead of and, right? If we'd had or here, then let's read this through. Well, it would say while goat not in x or horse not in x. What this essentially means now is that this code is going to run if either goat or horse is missing from x, right? So for example, if we typed goat as our input, it would come here and it would check goat not in x. Well, that would be false, right? Because goat is in x. That's what x is. However, horse not in x would return true, right? Because we have goat in there. And so because we had at least one true here, and that's how or works, right? Or says this has to be true or this has to be true. Well, we're going to run the code. In other words, we typed goat, which satisfies what we want, but this horse not in x is going to force the code to take new input, right? So this would not work because it's going to make sure that we have both goat and horse inside x. So what you should do now is just take a minute to test this, right? So start with and you'll see that this program should work fine. Change it to or, and you'll see exactly what I mean, that you'll have to have goat and horse in your string in order to make it work. Okay, so we're going to do one more example. Let's comment this one out. And we'll type example 3.3. No vowels. Alright, so this time we want to take a string that has no vowels, A, E, I, O, or U. Well, let's start with an input statement. Type a string with no vowels. Okay. So in our while loop, right, this time we want to take input again over and over if we can't find any vowels in the string, right? So this one's a little bit more complicated, but once again, I invite you to just pause the video here and see if you can think of a solution that would satisfy this problem. Okay, so this time, really, we just wanted to make sure to check that that none of these are actually in the string, right? So while A, right, is in X, or E is in X, or, and we just basically can go through the whole list, or I in X, or U in X. Right, this is what we want. A, E, I, O. We're missing O, right? X, or O in X. Okay, so there we go. A, E, I, O, U. Right, so while any of those are in the string, we need to print invalid and retake our inputs as follows. Okay, and so basically this should work. If we type a string with all consonants, then we're good. But if we type a string that has even one vowel, E, then it says invalid, right? O, there we go, A, because it's finding that vowel in there. That's how to do example 3.3. And at this stage, go ahead and practice this on Replit 0.9c, and we'll see you back when you're completed that. Welcome back. So, the next thing that we can do with a while loop is to take input repeatedly until a specific stop, string, or number is entered. In other words, for example, write a program to take a list of numbers and end when a 0 is input. When the list is finished, print out all the even numbers that were entered in a horizontal line separated by spaces. So we know how to check if a number is even, but how do we keep track of all the even numbers and then output them at the end? Well, we're going to use something called an output string that we're going to add to as we find the even numbers and print that at the end of the loop. So here we go. All right, so let's start by typing a comment here to introduce our program, list inputs. All right, and we're going to start with an output string that we need to initialize. In other words, give it a default value, and we'll make it empty. Now, every time we find an even number, we're just going to concatenate that even number to this string, right? So that with a space, if necessary, so that we can print this when we're done. Okay, now we need to take a bunch of numbers, right, and read them until the user inputs a 0. So because we have to check, first of all, if these are even numbers, really that means that our input is going to have to be converted to an integer. So that should, at this point, give you a little hint about what we have to use here, right? In order to keep our program from potentially crashing, we need a try except block because we're going to have to use the int function. But first, let's create a loop while true. And we'll break this loop if the user types in a 0, right? So let's actually just start by typing in X, or let's say current entry. We'll call it that, a little bit more informative, equals input. And we'll just leave this prompt blank for now. And so this is hopefully going to be an input. But first of all, if current entry is equal to, and let's put this in a string in quotes, 0, then break, right? So this is going to stop our loop from happening. And at the very end of this loop, after it's all done, right, what we can do is print output. And this will hopefully print all the even numbers that we've stored in our output variable. One thing to note here is that this 0 was entered in quotes because this entry is going to be a string, right? We didn't convert this to an integer here. It's a string value. And so to check if it's a 0, we just have to make sure that we're comparing current entry to the string 0 and break the loop accordingly. So next we need to check if this current entry is an even number, right? And so to do that, well, first of all, we're going to need to convert it to an integer and then check the remainder, right? Use the modulus function. So to do all this, of course, we need a try block because this is risky business, right? We can crash the program here if Python is not able to convert this string, whatever's been input here, into an integer, right? So let's put this in a try block, and then we'll start an if statement. We can say if int, right, input, or rather not input, but our current entry, right? Current entry mod 2 is equal to 0. What this means is that, hey, we've just found, we've just found an even number, and we can go ahead and add it to output. But the thing is, depending on whether or not we have anything in our output string yet, we want to add that differently, right? Because our output should eventually look like, a list of numbers starting with a number and then a space and then the second number and then a space and the third number, and it should be formatted nicely like that. So basically, right, if this is the first number, the first even number that we found, then we want to make sure to just add it straight away to output, right? And so how can we know that? Well, I mean, we do have this output string up here. So if we're in the loop at some point, we can always check and see if there's anything in here yet, right? In other words, if output is empty, then we know this is the first even number we found, right? And we can just concatenate it straight off. Plus equals current entry, which is still a string, right? We haven't actually converted, right, string to, we haven't converted this at all officially. This int, remember, this does not change what's in current entry. It returns, this evaluates to an int version, but doesn't change what's actually in current entry, which is still a string. So we'll concatenate current entry, but otherwise, right, this means that we've now actually found another output contains something, so it contains integers or even numbers already. So we want to add not just the number, but also a space first, right? Plus current entry. There we go. And so this should do a nice job of adding all the even integers that we find. Okay, and so there's really one last thing to do, of course, with this, and that's to add an except block, something that will run if this try block fails, if it can't convert it to an integer, right? Well, let's do this. If we type except, so what do we put in here? Well, we could put a prompt in, right? We could print something like invalid entry or whatever. But I mean, really, all this program says is to record all the even numbers that are entered. So we really just can ignore any other types of input that the user types, right, for this. So I mean, really, we could just type pass here, right? And that what this would do is just keep the loop running, right? If the user types something that can't be converted to an integer. And if we were adding prompts, then we could put one here. We could also put a prompt at the beginning that basically says this, like type numbers and add a 0 or type a 0 when finished. So I think here that this should be finished. Let's go up here and go ahead and comment those out, and we'll try this and see what we get. Okay, and so I'm just going to start typing numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. There we go. And we got 2, 4, 6, 8. And those are the even numbers that I typed. So let's try this again. Negative 10, 4, 5, 18, 19, 31, 41, 51, 62. All right, and then 0. Okay, so there we go, right? Negative 10, 4, 18, and 62 were the only even numbers that were typed, and the only ones that were printed. So this program is functioning just fine. And you can now go ahead and try Replit assignment 0.9D, and once you finish that, come back for one final example. Welcome back. Alright, example 5 says, write a brute force program to determine whether an input number is prime by searching for factors. So here's a couple key things. A prime number has no factors other than itself and 1, right? Like the number 11. Right? We can't divide 11 by anything but 1 and 11. Whereas the number 6, you can divide that by 1, 2, 3, or 6. And so 6 is not prime. So the key, right, to whether a number is prime is, well, are there any factors, right? Can we check the numbers that are less than a given number and see if any of them divide evenly, not including 1 or the number. So here is a stepwise refined solution. I'm going to leave these steps here so that you can browse through them, and if you'd like to kind of understand how I developed this solution in a little more detail, then feel free to read through these. But for now, we're just going to take the pseudocode that I've prepared here at the end and convert this to code. So this pseudocode runs as follows. Well, we'll take a number, right? The number that we want to check and see if it's prime. Then we need to initialize a counter, something that we're going to increment, and start it at 2, right? And basically start dividing our original number by this counter, right? So because if it divides evenly by 2, then we know we have a number that's not prime, right? So that's what's going to happen in the loop here. Now we're also going to need a Boolean flag, and we'll call this found factor. And we'll set this to true if we actually happen to find, something that divides evenly. So then we'll start our loop, right? And what we're going to do is loop until we find a factor or get to the original number, right? So we'll put this in our while condition, right? Because basically we want to make sure that this loop stops if we find a factor, right? This break command is going to help us with that. Then, of course, we need to increment the counter so that it goes up and up until we finally get to this original number. And at the end, display the result. Because if we have stored in found factor the value true, then that means that we found a factor and it is not prime, right? So, in fact, should be the opposite, right? So we should display not prime, otherwise prime. In any case, let's do it. So we'll start with a little comment here. Example 5, prime numbers. Okay, and let's start by taking a number. We'll say is prime. Okay, and we'll just call that our number that we're going to check, right? So is prime is going to store an integer, and now technically you should have this in a try catch block or try except block, but for now we'll just keep this simple instead of having another while loop up here. Okay, and now we need to initialize a counter, right? So we'll call it count, right? This is what we're going to divide is prime by. We'll set that to 2. And then, of course, found factor. We need a little flag that we can set to false. We start initially to false and set it to true later. And now we'll start our loop. Okay, so so we want this to run basically until we find a factor, in which case we'll break the loop, or until we get to the original number, until we get to is prime, the number that was typed in, right? So as long as count, which we're going to make bigger every time, is less than is prime, then we should run this loop block. Okay, so in this block, we want to, first of all, check if the current count can be divided evenly into is prime, right? And so we'll say if is prime modulus, right, count, right? This is the way that we check if something divides evenly. We check and see if there is a remainder after dividing. Okay, so there we go. So if this is true, this means we found a factor, right? So we'll set found factor to true, and we'll break the loop, right? Otherwise, we're just going to let this keep going, and we could make count bigger, right? So we'll check the next number, plus equals 1. So now this loop is going to keep running, and it's going to keep making count bigger until eventually it'll be equal to is prime, and this condition will return false, and then will be sent down here to line 60. Okay, and at this point we can check, right? We can check our answer. So if found factor Okay, and this means basically if you leave it just like that, that means if it's true, okay, if found factor, then we're going to print not prime, and otherwise we'll print prime. All right, let's test this out. In order to do that, we need to comment out the previous example, and let's see what we get. Okay, enter a number. Let's try 12, not prime. Very good. Let's try 11, prime. Okay, and let's try a tough one. How about 41? That is prime. And one more. How about 54? Not prime. Okay, well, so far it seems to be working. But in any case, this is how you could do, you could use a simple while loop to check for prime numbers, or check a number and see if it's prime. And what I encourage you to do, if you're not completely sure how this works, is to just cut and paste this code into the visualizer, right? That's pinned in the front of Edsby. Step through this, right, on the visualizer, and it will show you very clearly how this loop works. It's always a good exercise, and it's a great way to debug your program if you're wondering how and why unexpected things are happening in your program. Okay, at this point, there's a few more examples, a few more assignments you can do on Replit, E, F, and G. H is optional. It's on Fibonacci numbers. It's a little bit trickier, and once you're done those, actually, you can begin project 1, which is rock, scissors, paper. That's under 0.9i. All right, good luck with these, and we'll see you on the Flippity.